Hello, everybody. Okay, it's today is Friday. Oh man, I'm messing my dates up. 22nd. This is a science video. Okay, we're gonna pick up where we left off. We're on page 654. Okay, and the title at the top says "The Travels of Sound." Okay, we're right on this page right here. All right, so sound can travel through walls, windows, and floors, as well as air and water. Does sound travel at the same speed through solids, gases, and liquids? They show you this picture of this boy. I'm going to read right here, this caption. It says, the sound of this boy's voice moves through gases, which is air, and a liquid, water, the pool, before reaching the other boy's ears underwater. Okay, so if he's talking and you could still hear people talking when you're underwater, right? It might be muffled, it might not be as loud, but you could still hear it. All right, so I'm going to read the main paragraph. It says, sound travels in waves, but sound can only travel if there are particles in the waves if there are particles that the waves can cause to vibrate. Okay, so most of the sounds you hear move through the air. Air and other gases have particles and vibrate as the sound energy hits them. Liquids and solids are also made of particles, so sound waves can move through these materials too. However, if there's no particles to move, then sound cannot travel. All right, so particles are these little things in the air, okay? It needs to have particles to travel through. Almost think of it as like it needs something to attach itself to carry it, okay? To carry that sound across, its journey. So it says, however, if there are no particles to move, then sound cannot travel. So where are there no particles? Okay, so they're going to give you an example right here. It says, what would happen if an astronaut dropped a heavy rock on the moon? Would it fall with a thump? Since the moon does not have an atmosphere, there would be nothing for the sound waves to travel through. So dropping a rock would produce no sound. I thought that was kind of creepy. I remember learning that you can't hear in space, so if you screamed out, there's nothing to carry the sound waves. There's no particles. There's no atmosphere. We have an atmosphere made up of oxygen, okay, and hydrogen. So Earth's atmosphere is, allows it to project sound. Even in the air, when you're high up in a plane, it projects sound. Once you get past that atmosphere, nope, there's nothing to carry the sound. There's no particles, okay? So I just thought that was interesting. Move on to page 655. Okay, it shows the other boy that's underwater. I hate how they split these pages up, and I know you guys have them stapled together, but that's the boy who is getting called out to. Anyway, it shows another example down at the bottom. You see someone knocking at a door. It says, when you knock on a door, the sound moves through a solid, which is the wood of the door, and through a gas, the air, on the other side of the door. So it's moving through two different, what's it called? What's the word I'm looking for? A solid, liquid, or gas, whatever the atmosphere is made up of, okay? Sound waves travel through different kinds of matter at different rates. The speed at which the sound waves pass through solids, liquids, and gas has to do with how their particles are arranged. Okay, so solids, liquids, and gases all have their particles arranged differently. And you guys have learned this. I'm not sure if you remember it, so I'll review. Solids, actually it'll tell you right here in the reading, but basically, particles in solid are packed closely together. Remember, we did that exercise where I had you guys draw a solid and how close the particles are. You made little dots, and they were very, very close in a solid, okay? Now, the particles in gases are far apart, okay? Liquids are in between. So if we drew water, the particles were somewhat scattered, and they had some space, but they were somewhat close together. Gases, they're very spread out, okay? So solids, most tightly packed particles. Liquid next, and then gases, they're spread apart, okay? So for this reason, sound travels through gases more slowly than it travels through liquids and solids. Now think back to what I said. Think of it as something as for the sound to latch onto. If there's less particles in the same space, the sound is going to travel slower. If there's a lot of particles and they're closely packed together, the sound's going to travel to that and get absorbed by that very quickly. So a solid is going to absorb it very quickly, as opposed to a gas, the air. So we're not going to do this, but it's kind of interesting. It says do the math. You could see the speed of sound, and this is minutes per second in minutes per second. Type of matter is on the left. Okay, so we have pure water and minutes per second. Pure water travels 1,525 minutes per second. Dry air, only 300 minutes per second. And then cast iron is a big chunk of solid iron, 4,575 minutes. I'm sorry, yeah, miles per second. So you could see how much faster it travels through a solid as opposed to air, some sort of gas, okay? Moving on to page 656. This is going to talk about the amplification of sound. Okay, so it says sound all around. I'm going to read the main heading first, right here. Okay. Sound all around. Understanding the properties of sound allows people to control sound. Sometimes people want sounds to be softer or not to be heard at all. At other times, people want sounds to be louder or clearer. Engineers design rooms and buildings to reduce outside noise and to make indoor sounds more pleasant. Okay, I'm going to go to this box first where the lady's singing. Okay, I'm going to read that. It says, engineers use knowledge of sound's properties as they record music, voices, and other sounds in studios. Sound engineers also combine the singer's voice with the background music. Okay, and then the picture up top, it's half of the picture. Again, if you open up your packet and you connect it, the other half of the picture is on page 657, okay? This is insulation, okay? This is soundproofing material, all right? So I'm going to read right here by sound insulation. Okay, it says sound insulation contains tiny air cells. Sound is absorbed as the cells trap sound waves. This keeps the sound inside the room. Similar technology is used in apartment buildings to help limit the amount of noise you hear from your neighbors. So obviously, if there's thin walls and it's not very soundproof, it's going to be, and somebody's being loud in the next room or next apartment, it's going to be very loud and possibly annoying. So soundproofing is something that we've mastered. I've been in recording studios where you can't even hear the band playing outside of the studio because there's such good soundproofing. It's very expensive, but we have the technology to do it. So on page 657, it shows a large amphitheater, okay, where people perform. And it says, in movie theaters and performing arts centers, sound must be amplified or made louder, okay? Sound engineers place speakers in certain places so audience members can hear clearly. As a result, you'll never miss a moment of that new blockbuster. So also, those speakers are amplifiers in themselves. They're called amplifiers. So when you plug an electric guitar into a speaker, it's actually not called a speaker. It's called an amplifier because it's amplifying the sound of the guitar. Okay, it's making it louder. Okay, so in this box right here, it says control sounds. It says draw a scene in which a person might wish to reduce or amplify sound. Then describe what you have drawn. So it's up to you. Do you want to, if you want to draw a situation where you would want to reduce sound, you know, like I gave the example of apartment buildings, you know, that would be a thicker wall and some sort of sound insulation. And then if you want to amplify the sound, you know, draw something with a speaker or an amplifier. Large rooms amplify sound, okay? So performance centers, like in this picture right here, they amplify sounds. Okay, so that's your assignment for today. And that's it for this week. We'll pick up next week. We're going to do some summarizing, some wordplay with the vocabulary words. And so I hope everyone has a good weekend, and thanks for watching.